Okay, we are here in section 5.5, and we just got this handy roadmap for navigating indefinite integrals with the u-substitution method. And the idea here was that you'll start with an indefinite integral of f of x dx, and ideally, you would know its antiderivative off the bat, and you would just take that antiderivative and you'd end up here at capital F of x plus c. But it's not always that straightforward. Sometimes you don't know the antiderivative right off the top of your head. That's totally fine. So sometimes we need to use other methods or take longer routes. So you would start here with your integral, use a u substitution letting u equal g of x. That would allow you to convert that integral into the integral of f of u du. And then hopefully that's a simpler integral to look at so that you actually know the antiderivative and can take the antiderivative here, giving you capital F of u plus c. And then we want to get things back in terms of our original variable. So you use your substitution again, going the other way, putting things back in terms of x, so that you ultimately end up in the same place with capital F of x plus c. So sometimes we need to take the longer route. All right, so this is the substitution method, also known as u-substitution. Okay, this is kind of the common nickname for it. Okay, and u-substitution can be used to make finding antiderivatives easier, particularly in cases where, all right, we're doing an antiderivative. If in taking the derivative, the chain rule was used, okay? In cases like that, the u-substitution method can be really handy in going backwards and finding antiderivatives. So this is particularly helpful in running the chain rule backwards. All right, which we haven't really had much of an approach for that type of thing yet. Okay, so we're going to look at a little example here. And in this example, we are going to integrate negative 15x squared sine of 5x cubed dx. Okay, so if you can look at that and you know the antiderivative off the top of your head, that's great. Just take the antiderivative, make sure you get your plus c on the end, and you're good. And with this one, you know, some of you might actually be able to do that, but believe me, they will get more complicated. So if you don't know how to do the antiderivative of this right away, that's okay, because we're going to practice our u substitution on this. All right, so when you get a problem like this, one of the first things you'll kind of look for is to see if there's a pairing of some smaller function and its derivative in your integral. Okay, so what I'm talking about here is this 5x cubed and this 15x squared. 15x squared is actually the derivative of 5x cubed. And that's kind of a tip off that a u substitution might be helpful here. Okay, so what we're actually going to do is we're going to let u equal 5x cubed. Okay, so then if we do that, we know that 15x squared is the derivative. So du dx, the derivative of u with respect to x, is 15x squared. So notice how, if we look at this in a differential sense, think back a couple chapters to differentials, move that dx over to the other side. Du would be 15x squared dx. notice how both of those things are actually inside our integral here, 15x squared and dx. Interesting. So what we are trying to do here, remember, is to actually convert this integral from being in terms of x into terms of u. Okay, we don't want any x's left over in our integral at this stage. So we're trying to replace everything and substitute everything in a way that's going to get rid of all the x's here. So let me rewrite our integral. Negative 15x squared sine 5x cubed dx. And I've given it a little extra space there because different pieces of this integral are going to get kind of covered with different pieces of our u substitution here. We're letting u equal 5x cubed. So this inside here, 5x cubed, that is actually just going to be u. Okay. And then du is 15x squared dx. So 15x squared dx, those come together and are just going to get replaced with du. du. Okay. So notice that there are a few things left over. We've still got this negative and we've still got this sine function. That's okay. We're just going to carry those along to the new integral. All right. So this is going to equal the integral of negative that comes along. We're still going to have our sine function, but instead of 5x cubed, that's just a u. And 15x squared and dx both kind of fold into this du term here. And this is our new integral. We're going to integrate negative sine u du. Much better, right? This looks a lot easier to find the antiderivative, and that's exactly what we're going to do. So take your antiderivative. And yeah, it's a lot nicer now. So when we do that, we're just going to get cosine of u plus c. Okay. But we don't want to stop there. Right now, and as far as our roadmap goes, we are located right here. We found the antiderivative, but it's still in terms of u, which is not really what we wanted. We want to get back here where everything's in terms of x again. So we need to pass through our substitution one more time and switch everything back to x's. Okay, so instead of u here, we are going to switch this back to 5x cubed, and that's the only thing that was in terms of u. So that's all we have to change. So let me note here that we are going back to x's. And so we would end up with the cosine of 5x cubed plus c. And that is the answer for this indefinite integral, cosine 5x cubed plus c. And just like any other indefinite integral, you can check this. You can check your answers by taking the derivative, okay, and making sure that you actually get your original integrand back. Okay. So if we're going to take the derivative with respect to x of cosine 5x cubed plus c. All right, we would need a little bit of chain rule on this. That's why this u substitution method is so handy on the antiderivative. It's because this part of the derivative involves chain rule. So we are going to have the derivative of cosine as negative sine. Keep that inside the same, 5x cubed. Chain rule times derivative of the inside, which would be 15x squared. And then the derivative of c is just 0 because c is just a constant, remember. Okay, and so we end up with negative 15x squared sine of 5x cubed, which is our original integrand right here. Okay, so that tells us that this checks out. Our answer is solid. Very nice. Okay, so that is our first u-substitution problem. And in the next couple videos, we'll look at different ways to choose your u and different examples to give you an idea of how this works.